In this lecture, we're going to talk about the Maynes model of decision making. So, today's lecture is going to focus on one of the readings that you had earlier by Scott Maynes. And so, Scott Maynes is a consumer economist at Cornell University who devised a method of analyzing families' decision making. This model is based on the cost-benefit analysis from economics and decision tree model from management. Maynes says that risks occur if there is more than one outcome that can occur after a given action, and decisions are made under uncertainty. And basically, uncertainty is just different outcomes that flow from a given alternative. The Maynes model consists of 5 steps to get us to the best decision. The first is alternative actions. Second is possible outcomes. Third is subjective probability of outcome. Fourth is utility, and under utility we have an objective component and a subjective component. And the last step is net utility. So for the first step, like I said, is alternative actions. We will look at the best alternative action. For simplicity, we'll look at 2 or 3 most reasonable alternatives given the situation. But honestly, there is no general rule regarding the number of alternatives to consider. So I'm going to give you an example of a person who found out that a tornado was 2 miles away from where they live. So they came up with 2 alternatives. 1, to stay in the living room, or 2, to go down to the basement. Step 2 is to think about the possible outcomes for each action. Each action must have at least 2 plausible outcomes. So back to our tornado example. Let's say that our person has 3 possible outcomes for staying in the living room. 1, that they experience no damage and the storm passes. 2, no injuries to people, but the house suffers damages of $10,000 and insurance covers $7,000. And 3, worst case scenario, somebody dies and the house is demolished. So they had 2 possible outcomes for going to the basement. 1, no damages and the storm passes, or 2, no injuries to people and the house suffers $10,000 in damages. The third step is to assess the probability of each outcome. A probability is the likelihood that something will happen. So basically, we're trying to figure out what is the likelihood that a particular outcome will occur. Since we assume that only outcomes listed could occur, this means that the sum of the probabilities associated with each action will be 1. So let's look at an example of weather. So the weather person says that there's a 4 in 10 chance of rain. So in this example, there's a 40% chance of rain and a 60% chance of no rain. In the Maynes model, we're looking at the subjective probability, which are values assigned by the decision maker or ourselves. And these decisions are based on scientific data, prior experience, friends' data, or guesstimation. Again, we are the ones assigning a value. The fourth step is to assess the utility of each outcome. As we know, utility is the total satisfaction we get from a particular outcome. Under utility, there are 2 components, objective and subjective, that are also broken down into 2 additional subcomponents, objective costs and benefits, and subjective costs and benefits. So going back to our tornado example, the objective benefit are easily measured. They are the direct or actual savings or gains, like the $7,000 that insurance will pay for damages. The objective costs are also easily measured, and they are the direct actual outlays or losses, like the $10,000 loss in damages. Subjective benefits are more difficult to measure because they are mental or emotional sources of satisfaction, like relief or comfort. Subjective costs are also difficult to measure because they are mental or emotional sources of dissatisfaction, like anguish or discomfort. Like if a family member dies, there is no monetary compensation for the pain of the loss. Net utility is the combination of subjective and objective components. This is what we use to make our decisions. When it comes to the Maynes model of decision making under risk, we have to remember that we are using decision rules to decide what action to take. But it does not determine an outcome. Again, we use a decision rule to decide upon an action. We have to note that in risky decision situations, people cannot decide an outcome. We can only select an action. So now that we understand the setup and concepts for decision making, we can now move on to the rules. So there are 4 rules for decision making. 1, maxi-max. 2, best of most probable. 3, mini-max. And 4, highest expected value. So maxi-max is also known as the optimist rule. And honestly, this decision rule is pretty straightforward. First, we list each outcome with the highest net utility. But for this, we disregard subjective probability. Next, we ask which has the highest net utility. We then choose the option with the highest net utility. So for our tornado example, we will choose the first option, which was to stay in the living room and nothing happens and the storm passes by our house, because that has the highest net utility of 0 compared to the other alternatives. This rule does have its problems because it can also be the rule of the naive. This is because less desirable outcomes do occur, which are not accounted for because we have disregarded subjective probability. The best of most probable rule is like a risk calculator rule. In this rule, we first list the most probable outcome. Second of those listed, we select the outcome with the highest net utility. And then we choose the action associated with this outcome. This rule has its philosophy. Choose the action that has the highest utility and highest probability. So again, if we look at our tornado example, we would choose the first option, which had a high probability of 95 and the highest net utility of 0. Meaning that there was a 95% chance that the tornado will not touch down or will bypass our house and we would not have any damage to our house and nothing would happen to our family. Like the maxi-max rule, there is a problem with this rule. It does not take notice of some outcomes that might actually occur. So again, for our tornado example, this rule does not account for the fact that the tornado might touch down and destroy the person's home or their lives. The third rule is the mini-max rule, which is also known as the pessimist rule or the best of worst rule. For this rule, we would list the worst possible outcomes, which would be the outcome with the lowest net utility. Out of these outcomes, we will select the action that has the best or the highest net utility. So going back to our tornado example, this will cause us to choose option 2 or option B, which was we go down to the basement and our house experiences $10,000 worth of damage, but nobody is hurt. This rule has its philosophy to take the action which avoids giving the worst possible outcome a chance to happen. We see this rule as a recipe for disaster prevention. It will keep a possibility disastrous choice from being made. Or rather, We see this rule as a recipe for disaster, as it will keep a possibly disastrous choice from being made. Like the other two rules, there are problems with this rule. Like the maxi-max, it disregards the probabilities. These rules may still fail to point out the optimal choices if there remains two or more actions among which to choose. The last rule is the highest expected value rule, or also known as the utility maximization rule. So first, we calculate the expected value of net utility, or for each action. Second, the formula for the expected value is found by multiplying the subjective probability by net utility and then summing these products. So in the next set of slides, which I'll post later, we'll actually do a few examples with a scenario, and it will have probabilities and it will have utilities, and I'll show you how to actually calculate each thing, and it will make more sense once you actually see an actual example. And then after we go through that, then we will do a few exercises actually putting the formulas that we've learned, or the decision rules that we've learned, into action, and we can see how it actually works. So that concludes this lecture for today. Stay tuned for the next lecture that now goes into working out the different decision rules. All right, have a wonderful day. Thanks. Bye.